Find the length of line segment DE in feet. In this problem, points A, D, E, and C are located on a sag vertical curve, and their elevation values are provided in the table. The curve begins at point A and ends at point C, and the stationing of these values is provided as well. Point B is located behind the table at the intersection of lines tangent to the curve at points A and C. Since no data is provided for point B, we can remove it from the table. The problem statement also provides the slopes of tangent lines AB and BC. The length along the curve from point E to point D equals the station at point E minus the station at point D. The problem does not explicitly provide these station values, but they can be determined if we know the equation for the horizontal line which contains line DE and the equation for the curve AC. We'll designate these two equations as y1 and y2. And if these two lines intersect, the station or stations where they intersect can be determined by equating line y1 to curve y2 and solving for the unknown variable. If the line and curve intersect at two locations, D and E, as shown in the figure, then the length between points D and E can be rewritten as x2 minus x1, where x1 and x2 are the roots of the quadratic equation 0 equals y2 minus y1, where x2 is greater than x1. First we'll solve for y1, the equation of the line which contains line segment DE. From the given data, we notice points D and E share the same elevation value of 176.8 feet. Therefore, we know that equation y1 equals 176.8 feet. The equation for y2, which represents curve AC, is y2 equals r over 2 times x squared plus g1 times x plus the elevation at the beginning of the vertical curve. In this equation, the elevation at the beginning of the vertical curve is the same as the elevation at point A. The variable g1 refers to GAB, the grade of the line tangent to the curve at point A. Lastly, the variable r refers to the rate change in slope, or the change in grade along the length of the curve, which equals g2 minus g1, all divided by the length of the curve. In this equation, g2 and g1 refer to the grades of the lines tangent to the end and beginning of the curve, which are equal to GBC and GAB, respectively. The variable L is the length of the curve from point A to point C, and equals the station of point C minus the station of point A. After plugging in these given station values, 3,600 feet minus 2,400 feet equals 1,200 feet, or 12 stations. Substituting in this length and substituting in the two grades, the rate change in slope equals 0.583% per station. Plugging this value in for R, as well as GAB and the elevation at point A, we now have our equation for y2, where x is in stations and y is in feet. Now we can equate line y1 and curve y2 to solve for the points of intersection. After setting this equation equal to 0, we can use the quadratic equation to solve for the values of x1 and x2. After identifying 0.2915 as A negative 3.0 as B, and 1.6 as C, x1 and x2 equal 56 feet and 973 feet, respectively. After plugging these values in for x1 and x2, the length of line segment DE equals 917 feet. When looking over the possible solutions, the answer is D.